Hello, my name is Julian Fischer. In this video I'm going to show you the anynines Cloud Foundry services. Anynines Cloud Foundry services allow you to add production-grade backing services to your Cloud Foundry runtime. In contrast to most existing solutions, the anynines services allow Cloud Foundry users to instantly create on-demand provisioned and highly available service instances. After setting up an anynines Cloud Foundry service, a9s MongoDB in this example, we open a terminal with the Cloud Foundry CLI. At the Cloud Foundry marketplace, we can then find the anynines MongoDB service. By executing CF create service commands, we can now create dedicated MongoDB servers and clusters. In this example, we choose a small single VM plan and name the service instance for later use. The anynines service implements the asynchronous service broker API. You can see that as the request to provision a new MongoDB server VM returns immediately. While in progress, you can always poll the current state of the service instance provisioning. During the creation of our MongoDB service instance, virtual machines are being started in the background. In case of a single node MongoDB, a single virtual machine is launched. In case of a MongoDB replica set, 3 virtual machines are launched. After our service instance has been created successfully, we can see this in the service overview. From this moment on, we can bind this service instance to our applications. Looking at the environment variables of this application, we can see the credentials that have been created for this application exclusively. The credentials are provided by the anynines service broker and Cloud Foundry as application environment variables. Here we see the host name of the host running our MongoDB service. Note that it contains a host name and not an IP address. This leads to the benefit that IP address changes have no impact on service bindings. During the creation of a service instance, the anynines service also creates Cloud Foundry security groups. These security groups act as a firewall and, by default, prevent apps from foreign Cloud Foundry spaces to access our apps. The naming of these security groups follows a simple schema. The security group name contains the name of the corresponding service instance. Once created, we can update any service instance using the Cloud Foundry command line utility. One use case of such a service instance update is to add additional parameters, adding a Graphite endpoint for example. The anynines MongoDB service then streams MongoDB and VM-specific metrics to the Graphite endpoint, such as the memory usage and CPU usage. Furthermore, it is possible to add a syslog endpoint which will then receive MongoDB-specific log messages. Again, we use the CF services command to gain insights into the current deployment process. As we can see, the service update is currently in progress. Once the service update is completed, we can see in the Grafana dashboard the metrics which have been streamed to the corresponding Grafana endpoint. This dashboard shows some exemplary metrics. In this example, you can see VM-specific metrics such as CPU, disk, and memory usage, as well as the memory capacity. You can also see some MongoDB-specific metrics, such as the number of read and written documents. This Grafana dashboard is just an example. There are many other metrics that can be used to assemble custom metric dashboards. Besides of the update of configuration parameters, we can also scale out our service instances by upgrading to a bigger service plan. Using the CF service command again, we can see the upgrade being in progress. During the plan upgrade, the service instance's virtual machine will be replaced by a larger one. In case of a single node service plan, this will cause a short downtime. For a clustered service plan, a MongoDB replica set cluster will be deployed consisting of 3 dedicated virtual machines. During a scale-out of such a clustered service instance, individual cluster VMs will be replaced one by the other, and the service remains available during the entire upgrade process. After the service plan upgrade has succeeded, we can see the increased resources at our Grafana dashboard. We can see that after the service plan upgrade, our virtual machine now has 2 CPU cores and that the memory capacity has been doubled. Let's have a look at the application which is bound to our service instance and create some test data. In order to remotely access the service instance, for example to create a backup, we can establish an encrypted tunnel to our MongoDB. In order to make this happen, we have implemented an anynines plugin extending the Cloud Foundry CLI. CF create forward establishes an encrypted remote tunnel to our service instance. We can close this remote tunnel at any time. We can use these access credentials to securely connect to our database instance from our local development machine, for example. Here we can see the host we have created with our application. Once the remote connection is not needed anymore, we can shut down the encrypted tunnel entirely.